Hello students, I would like to have this video to walk you through a little bit more about how to draw the proper stereo correct product of the Diels-Alder reaction. Remember there's an exo product and an endo product, so I would like to guide you through a little bit better on understanding the endo product. Okay, so in a Diels-Alder reaction, there's always going to be a diene and a dienophile. Okay, now there will all for a for the stereochemistry to be applied, you have to have substituents on these on the ends of these dienes and dienophiles. So I'm going to label them as A, B, C, and D generically. Okay, so call this A, call this B. Right, so A are the substituents on the diene that's facing away from the dienophile, and B are the substituents that are facing towards the dienophile. Similarly, in the dienophile, you can have substituents are facing your diene and substituents are facing away. So something here to keep in mind is that C, you always want to have C as your electron withdrawing group, because that's going to have a perfect alignment. You want your electron withdrawing group to be facing the diene, so that when you form your transition state, your electron withdrawing group is stabilizing the newly formed pi bond. That's going to be there. Okay, so when you form in a Diels-Alder reaction, let's draw in some arrow pushing here. So let's say that your bond attack here, and therefore goes there. So your new product is always going to be this six-membered ring, because you have how many carbons? 1, 2, 3, 4, 5, 6, right? So it's always going to be a six-membered ring because it's a 4 plus 2 addition. 4 carbons plus 2 carbons, making 6 carbons. Okay, so if the diene did, and again, you can have the attack coming from the top or from the bottom. It doesn't matter as long as you are being consistent about it. It's going to be just plus enantiomer, right? So I always like it for your diene to be on top and your dienophile, your double bond, to be on coming from the bottom. Now, so imagine when some two things collide together, what happens? They push each other out, right? So I always like to hold my two fingers like this, where the fingers that are being depicted are the substituents between the two molecules are facing each other. So what would my diene hand represent, A or B? It would be B, right? What about my dienophile hand? What would that represent? C or D? C, right? So these two fingers only represents B and C, and A and D will just be the resultant stereochemistry. So we don't worry about them for now. Okay, so for example, if B is on top and C is on bottom, when they come together like this, what happens? When they collide, it pushes each other's out, right? So when they collide, push each other out. So therefore, B is facing up and C is facing down. So that's how I like to think about that. Okay, so where is B? Remember, B was going off of here, and we just said that B was going on top. Okay, and where is C? Remember, C was on these two carbons here, and we just said that C was going to be back. Now, here's why you only care about B and C, because A is also connected to the same carbon as B. So if B is facing up, then there's only one more position left, right? So A must be going backwards. Correct? Same thing with D. If D is on the same carbon as C and C is going down, then D must be going up. Okay? So that was one product. What about if you have your diene yeah, if you have your diene from the bottom and your dienophile on the top. Same thing happens once again, we're going to collide B and C facing each other. When they collide, they're going to pop each other out. What happens to C? C is now up and A is now down, right? So your other product, what did I just say? C is up and B is down. Therefore, A is up and D is down. Okay, so these are your two products. You can just in this class just say this and say plus enantiomers, and that's okay too, as long as the relative stereochemistry of A, B, C, and D is correct. That's all we really care about. So let's do an example of this. What about this case? First of all, I would redraw this molecule so the diene and dienophiles are matched, as in the negative is attracted to the positive ends. So let's draw the resonance structure to show where the negative charge is on the diene, and we have seen that it is in that position in the bottom there. So I'm going to go ahead and delete that so that not to confuse you. So we know that this is where the most negative part of the diene is. What about the dienophile? Remember, to redraw the dienophile, I can simply draw it like an aldehyde that way. And if I drew in my resonance structure, I can see that this is now going to be your positive end, right? Oops. So if that's your positive end, then it's already matched. We don't have to redraw it. All we have to do now is go ahead and see how this does the attack in, right? So we get, first off, we get this cyclohexane with the double bond. Oops, we forgot there's a double bond in all those examples up there too, right? With the newly formed double bond there. Now, let's consider this dienophile is coming from the bottom, and this diene is coming from the top, okay? So what are my fingers going to represent? Remember that when we are drawing our dienophile, our electron withdrawing group must be facing the diene in order to stabilize the newly formed pi bond. So again, I would have to redraw this. Inward like that, okay? So that CHO now represents the C, because that's a group that's facing towards the diene, and this as H there, okay? I draw in the H so that we are not too confused, right? So what is the B substituents here? The B substituents here would then be H and also another H. Okay, I draw all those things in to make sure that I am drawing it correctly. Okay, so now go ahead and do our trick here. If this dienophile is coming from the bottom and a diene is coming from the top, what's going to happen? They crash. They come together, they crash. So your dienophile is going to be, the CHO is going to face in the bottom, right? So it's going to mean, so that means it's going to go down. What about this hydrogen right here? Remember, it's the fingers of the diene on the top. So it's going to crash, it's going to go up, right? So that hydrogen is up, therefore this hydrogen is also up, meaning then that this amino group is down. Okay, so that's your product. Of course, you could say plus enantiomers. Now, of course, when you form a center that is not a chiral center, you don't have to really draw these guys in. Simply this could be the answer, or you can just simply draw it like that also. Both are acceptable answers there. And so hopefully that helps you a little bit on how to draw your endo product.